Okay, so let's quickly go through chapter 7 in this morning. This will be about managing projects and, well, probably like package management, dependencies, and everything. So it will be. So this is just the introduction. Yeah, probably we'll be learning how to use Kaggle. So Kaggle provide workspace, which we'll be learning more in chapter 14. Um, I don't think we are diving into detail right now, but we will learn something about Kaggle. And call your code about maybe is it also about how to package things and stuff? I don't know. I think the best way to know is to jump into it. Cargo feature lets you build, test, and share crates. A tree of modules. Yeah, I found it like very frustrating when I learned Python, like another packaging and how a project should look like and stuff. I think now there are like cookie cutters that you can use to help you make to build a Python kind of project very quickly, but it's not something like so standardized. There's no really like no kind of very structured like kind of official thing in Python to tell you what's the best practices and stuff. But yeah, this is good that they have a section like that in the book, so I can learn about that, how it's handled in Rust. I think Cargo would handle most of the thing for you as well. So let's see how we're gonna see all these features, how we work with them. So let's go. Okay. Packages and crates. Crates is the smallest amount of code that Rust compiler consider at a time. So if you run Rust C rather than Cargo and pass a single file, which we have done like in chapter 1 a long time ago, the compiler considers that file to be a crate. So this is different from module. It's just like a small unit of code. But crates can contain modules, and modules may be defined in other files that get compiled with the crate, we'll see in the coming section. So, yep. So it could be very small. A crate could be just like a file that you run Rust on, or it could be more complicated that have modules and many other things that are included in it. So, a binary crate or a library crate. A binary crate are programs you can compile to an executable that you can run. It's a command line program or a server. So yeah, it's a binary file. Each must have a function called main that is executable. So library crate doesn't have a main. So again, like understanding in Python terms. So in Python sometimes we have to if name equals to main, then run that. So it's basically just running a Python file. But there's also like some other things, like for example a Python library that you pip install that you just don't run it, right? You just use it in other things, like for example pandas, right? Pandas, you use it in your code, you import it and use it. You don't run panda as a command line tool or whatever. So that's the difference. So binary is the one that you execute. So it's a program that you run it. A library crate is doesn't have a main, so it's not meant to be executable, but they are actually shared. So it's kind of like a library that you share with multiple projects. The ran crate we use in chapter 2. That would provide something you can use, like the random number generator. Library crate, yeah. Yeah, this name, I'm the like the worst you know person regarding names and stuff. I use a lot of terms like interchangeably, like probably wrongly and stuff. But in the Rust world, yeah, crane is used interchangeably with library. Yeah. Crane roots is the source file that the Rust compiler starts from and makes up the root module of your crane. Okay, package is a bundle of one. So a package is a higher level structure. It's contained a bundle of cranes that it provides a set of functionality. So a package will have a cargo.toml file that we have seen a lot of times. So that file is kind of describe how to build those crates. So yeah, like in Python terms, it's like the pyproject.toml kind of thing. So we have cargo.toml for us. Yep. So cargo is actually a package that contains binary cranes. So cargo is a package. It got multiple cranes in it, and the command line tool that you're using to build the code. Just also have another crane that you can that do other things that the binary crane depends on. So other project can also use the cargo library crane to use the same logic. Yeah, so cargo is a big thing. So it's a package, and it contains some like the tool that we use many times now. But it also has a has other cranes that you could use if you want to build your thing, kind of depending on cargo. So yeah, cargo new, we've done it. So we would have the cargo.toml file, the source folder, and a main rs that is inside. Yeah. So yeah, so it already built kind of like a structure for you, and also I remember like it started also a Git repository as well, so it does a lot of things for you. So convention, create a root of a binary crate, the same name as the package. If the package directory contains, so if we have a librs instead of the main rs, so passes the crate root file to Rust. Let's see a bit of library of binary. So yeah, if it's a library crate, you probably have a librs if you want to build a library crate. So all right. Yeah, if it's only the main rs, that means that we only have a binary crane named my project, because the name of the project is my project. If a package contains the main rs and the librs, then you will have two cranes, so they won't get mixed. So you have a main rs and a librs. So you don't have to do the funky thing of like Python, you know, you have the main equals to name equals to main, because you put everything in one file. You put the other thing that the other Python file can import in the same file as the main one that's supposed to execute. So yeah, no, but in Rust you have to put them in main or lib. It will create two cranes. It will create a binary and a library. Both have the same name. Package can have multiple binary crane, and they will all put in a bin directory. Each file will be a separate binary crane. Okay, cool. Defining modules to control scope and privacy. Ooh, okay. Path. The use keyword, so we have used that before, kind of like import in Python. There's also the pub keyword to make things public. The us keyword. So there's a lot of things we're gonna cover in this chapter. Whoa. A list of rules. Okay, so this will be like probably useful in the future because this contains some rules. So how the use and the pop keyword use in work in the compiler. So start from the crate root. So when compiling a crate, the compiler first look in the crate root file. So look for the librs or the main rs for code to compile. Declaring modules. In the crate root file, you can declare new modules. Say you declare a garden module with the mod garden. The compiler will look for the modules code in this place. So inline with curly bracket that replace the semicolon. So yeah, so it will be like after this it will be a curly brackets. Or in the file, so you can have a garden.rs or garden and then inside is mod.rs. Yep. So this is how you can declare a module. So if you just put it like that, you have to have it in another file like this, I guess. Declaring submodules. So in any files other than the crate root, you can declare submodules. For example, you may declare mod vegetable inside the garden rs. The compiler will look for the submodules code within the directory name for the parents module in these places. So you can either like put it inline within the garden rs here, or you put it inside the garden folder. So it'll be vegetable.rs, or you can expand it to another. So you will have submodule of the vegetables, so submodule can have submodule as well. So path to code in module. So this is how you declare a module. So a module is part of your crane. You can refer to code in that module from anywhere else in the same crate. So once it's attached to your crane, then it's available to anywhere in the crane as long as the privacy rule allows. Using the path to the code, for example, asparagus would be available like that. So you start with the crate and then the garden and then the vegetable and then the asparagus. So, right. So private and public. So how to make things public or private. Code within a module is private from its parent module by default. To make a module public, declare it with the pub mod instead of mod. To make item within a public module public as well, use pub before the declaration. So if you want to make anything public, you have to use pub mod. Otherwise, it's only within the parent module. Use keyword. Within a scope, the use keyword creates shortcuts. So it's kind of like from something import something, then you don't have to refer it the full path. If you use, then now here you can call asparagus. Because you say use, then it doesn't need to provide the same path. It's just this asparagus the last one will be available to you. Okay. Here's the create a binary crate named backyard that illustrate the rules. So we have these things, and then the crate. Let me put it a little bit here. Make it a little bit bigger. The crate root file in this case is the main rs. So it will contain. So this is the main rs look like. It will use the use, and then pub mod garden. So the garden will be public, and then I'm growing plants. That's asparagus apparently. Yep. Tells the compiler to include the code if found in the garden.rs, which is so it will find the garden.rs here. So this garden RS will have the mod vegetable, and then we will look for vegetables, which is here, and then yep, we have the structs, which is nothing right now. Grouping. We can also control the privacy with modules. So yeah, it's by default it's private. So unless you make it public, it's not public. Private items are internal implementation, not available for outside use. Choose to make module and items within them public. Right, a library crate that provides functionality of a restaurant. We will define the signature functions but leave the body empty to yeah. So it doesn't matter the implementation, we just want to make the structure. In the restaurant industry, some part of the restaurant I refer to a front of house, which is where probably you sit and dine and the waiter will come to serve you. Others as back of house, which probably is the kitchen or where they wash the dishes. Front of house is where the customer are, yes, and then yeah, also like where the bar is, where they take a payment, the till, you know, and like where bartender make drinks. Back of house is where the chef and the cook works, dishwashers and managers. So there may be a back office, so the manager can do the accounting. Structure our crane this way. We organize this function into nested modules. So now we are doing it ourselves. So we're gonna do the cargo new restaurant and then dash dash lib. Then we create one that have also the lib RS as well, I guess. But this is new to us, so let's do that. So sorry. Sometimes it's too early for me. I don't know what I'm doing. Okay, so cargo new restaurant lib. So we have that. So let's find the restaurant here. So let's close the other thing. And here we have the lib RS instead of the main RS. So, yeah, so this is just an example of how to add things. But, okay. So this is the front of house section. So we can put that in the lib RS. So hosting, add to wait list, sit at the table, serving, take order, serve order, take payment. So there, yeah. So we'll put it here, right? Okay. The body of the module can then go inside the curly brackets. We are kind of declaring it inline, so we don't have to have a front of house.rs. The module hosting and serving module can also hold definition for other items such as structs, enum, constraints, trails, and many other things that we'll learn in the future. Yeah. Using modules, we can group related definitions together and name why they're related. Yeah, so it's very like clear that, you know, oh, if we are sitting people down, then it's hosting, so probably sit at table will be at hosting, and taking order will probably be serving. So make it easier to find definition. Yep. From module name create at the root of the, so create means create root here. We have a module tree like this. This is the tree of the module, so we have two modules. So we have the front of house first and then two modules with inside. There's different functions inside. Yep. Tree shows how some of the module nested inside one another. So hosting nested inside front of house, these things. remind you of the file system. Yeah, it kind of look like a file system, but this is the module tree. Kind of similar. So there you go. So this is chapter 7.2. So let's go to the next one, 7.3. Path for referring to an item in the module tree. So yeah, how to find the item within the tree. So you can take an absolute path, which is like the full path from the root. So for the code from external crate, the absolute path begins with a crate name, and for code from the current crate, they start with the literal crate. A relative path starts from the current module and uses self, super, or an identifier in the current module. Right. Yeah, so it's like relative to where you are. It's using relative path. So we'll use a lot of colon to see what, like, to kind of go deep one layer. What I call the add to wait list function. Yep, so how to do that? So 2 ways to call add to wait list function from a new function, eat at restaurant, to find the crate root. This path are correct, but there's another problem. Prevent the example from compiling. I think it must be the public thing. Yeah, part of the library's public API. So eat a restaurant is public. So mark as pub, and then here it's absolute path, this is relative path. First time we call the add to wait list function in the either restaurant, we use the absolute path and the add to wait list function. So I want to see what's going on if I am being naughty and add it here. Can I do this? What happened if I, because there is not a main RS, what happened if I do cargo run? I'm interested. Oh, a bin target must be available. Yeah, so I think because they say lib.rs, so it won't run. But anyway, let's keep reading. The first time we called so yeah, this is the absolute path. So just define the same crate. Can use crate keyword to start navigating. Yep. The root is crate. Second time is a relative path. The front of house is the name of the module defined same level, so this is the same level. Choosing whether to use a relative or absolute path is the decision you make based on your project, depending on whether you are more likely to move definition. So yeah, both of them will work, but absolute or relative is your choice. If we move the front of house module in and then yeah, put them in the customer experience, then we need to update the absolute path, but relative path will still work if they got moved together. But if we move the eat a restaurant into another place, then yeah, then the relative path will not work as well. So yeah, it depends on your use case. So if you move things, so some of them will be broken. So it depends on how you may move things. So we have a problem because we it's private, right? So because hosting is private by default. So if we just call it here, then it will probably not work. So because hosting is only available within the front of house. So, yep. Error message saying that the module hosting is private. The paths are correct, but it's not public, so we can't do that. The parameter. How can you compile that though? It won't compile. Let's try to compile this thing. I can't use cargo run, no? Or cargo build maybe. Cargo build will work maybe. Right. Yeah, we have the same problem because yeah, hosting is not. So if I do so this one first of all need to be pub, I guess. So if I make this pub, then will it still show at me? I think it will, but let's see how it goes. Yep, it still have the problem, so I think everything needs to be pub now. And then this one. Let's see. Yeah, now we have the warning, which probably, yeah, it's not used, but it's fine. But it compiles. It just got a lot of warnings because I haven't used those. So you have to make them public. So like exposing path with the pub keyword. So this is what I did the first time, but it still have an error. Yep, because all of them need to, not the front of house. So yeah. Because add to wait list need to be pub, so this one doesn't need to be pub. I think because this is at the same level, so this one is available to this one. Because this one is available within the parent, which is the crate, so this is available to everything in the same crate, not for the external API though. So it should work. Yeah, it will work because yeah, you don't need pop in front of house because front of house is available for everything in the crate. It's at the top level, but anything inside you have to make it public. Yep. Okay, kind of straightforward. Best practice. Package can contain both main and the lib. Just enough code in the library binary crate to start an executable that calls code in the library crate. So you want to put a lot of things in the library if you have both. Yeah, the library's code can be shared. Any public item can be used in the library step by starting the path with the same name of the package. So yeah, if you want to share it to the binary crate, you also have to make it public. Because if it's not public to you, it won't be public to anybody else. Yep. In chapter 2, we'll dive into the detail. So start relative path with super. So now we are just kind of using things on the same level or below. But what if we want to go one level up, then we have to use super. So deliver order, and then back of house. We copy this. Right. Let's put it here. So fix incorrect order, cook order, and then super deliver order or cook order. Right. So cook order is available in anything inside here, so you can use it here. But deliver order is outside, so you have to use super. Situation: chef fix an incorrect order and personally bring it out to customer. Oh my god. Fix incorrect order, defines the back of house module. Yeah, because deliver order is in the parent module because the chef has to go out from the back of house. So we have to use super. Yes, like the dot dot in the file system. Fix incorrect orders in the back of house module. We can use the super to call the parent module and then put the crane root and look for deliver order. Success. Making structure and enum public. Yeah, so you can also make. So back of house would have a breakfast or summer. There is a toast. So what's going on here? Let's put it here. I don't like it. It's not doing this properly. Okay. So now we have a struct. This called breakfast is in the back of house. Is this public? So you can call it from outside because someone need to eat it. And the toast or seasonal fruit. So only toast are public. And then within the so this is within the back of house there is a function called breakfast. Yeah. There is a implementation of breakfast inside. And then within the breakfast what am I talking about? I'm too tired. It's very early for me because I have jet lag. I still have jet lag. For me, it feels like it's super early in Colombia. So, back of house, we have a struct that's called breakfast, so implementation of breakfast. So, we will have a function summer attached to breakfast. So in the summer, we would provide a breakfast, and then it will be a breakfast with a toast, and with the seasonal fruit will be peaches. So whatever toast it is, it will put some peaches on top, I guess, if it's summer. Yeah. So we can now eat at restaurant. Order breakfast in summer with rind toast. I'll put it at eat a restaurant here. So meal is mutable. So it's the back of house, breakfast, and then summer and rind. So we want a summer toast with rye bread. Oh, sorry about the noise. It's my door. Let me fix that. 1 second. Right, I'm back. Okay, so we ordered summer toast on the rye bread, but then I changed my mind. I want to have a toast. So the toast now will be a wheat bread instead of rye bread because I don't like rye bread. I would like a meal toast, please. We are not allowed to use so if you can't allow to change the seasonal fruit to blueberry, only the chef can change it. It's because seasonal fruit is not public. So summer is public, you can use summer here. The toast is public, you can change the toast, but you can't change the fruit. The fruit is not public. So yeah. Return to breakfast with, yeah, okay, cool. So yeah, if you want to see it in action, we can also do like the build, and then it will, it will still give you a warning because we haven't used a lot of these things. Oh, I haven't saved. Okay, yeah, still complained. Seasonal fruit. There are warnings, but it still compiles. It's just that it will warn a lot of things. But if we uncomment this, then we would have a we will have a problem. We will have this is private, so it won't compile. So okay, because yeah, the chef design what fruit you get, probably. So you can also have an enum. Enum is an appetizer. So either soup or salad. So we can put that in the back of house as well, maybe together with the breakfast. Where I don't want to put it, I don't mind. And the indentation is awful. Okay. And eat at a restaurant, we can have order one is having soup or salad. Oops, why do you do this? Okay. Right. So yeah, appetizer is public, so soup and salad can be eat at restaurant. Unless the variants are public. It'll be annoying to add, so if the enum is like appetizer is public, then everything, the soup and salad is also public. So default for enum variants to be public. So structs are often useful without the field being public. So struct is different. So for struct, each of them need to declare whether they're public or not. But for enum, when it's public, then everything is public. So that's the difference. Because yeah, it's just very annoying usually, because if one of them is public, like then probably all of them are public for enum, but for struct it's not, because each one of them may function differently. Last module system, the use keyword. So yep, let's move on. We have 2 more chapters. Bringing path into scope with the use keyword. So I think we have used it a little bit before, but let's see how it goes. So we can shortcut it by using use. I like to put it at the front. So now front of house hosting is splitting into the public, so we don't have to do this. We can just do this. And then it should still work. Yeah, it just get the warning. It's fine. Yeah. So hosting. Wait list, okay. So use also checks privacy like the other paths. So and now hosting is public, right? So it's fine. And create shortcuts for the particular scope. So for example, if I make hosting not public, and we should see a problem. Yes, now we have a problem because it's not public, so it should not be used. So yeah. It's only in the scope. So if we do this, move the restaurant function as new child module to our customer. So this one won't compile because it's in a different scope. So for example, if I put it as mod customer, if I do this, then then if the hosting, it won't work, this one, because it's only available in the top level. So over here we have to, can I do super? Can I fix it like that? And the super go up one level and then we have hosting there, right? So maybe that will work. Oops. Okay, so now it's complaining something else. Is it back of house? Is also not here, so we need to super it as well. So super the back of house. Oh, come on. Yeah, now we go back to all the warnings. So, yep. And then creating idiomic use paths. So use grave. Yeah, why can't we use other way? So yeah, you can also add the waitlist and do this, accomplish the same task. Bring the functions parent module in the scope means we have specified the parent module. So yeah, it won't be like, oh, where does this add to waitlist come from? If you stop here, then you know it's from hosting. Means that we have to specify the parent module. Yep. Makes it clear that the function isn't locally defined. We still minimize it. But yeah, it's always a good idea to include the parents as well. If you plan to use like add to waitlist and include hosting, because then you know add to waitlist is coming from hosting, it's not the local one. Bring in struct, enum, and other item we use to specify the full path. Hash map. Yeah, so if you call in the struct enum and other item, then you can do it the full path. Yeah, function parents is desirable to be in, there, but for struct enum and other things, then you don't have to. There's no strong reason behind it, it's just convention. Yeah, so it's just function that it's good to know where the function coming from. For the others, is okay, don't care. I guess because function name is like a lot of times you share the same function name, so it will be very confusing if you kind of bring all of them like all the way to the full path. But if you have the parents and then then you will know where that function is coming from. But for like other items like struct and enum, they are items, so they probably shouldn't share the same name anyway. So yeah. Okay, the exception. Bringing two items with the same name. Yeah, if it's the same name, then you should probably keep the parents. Bring two result type in the scope. Refer to them. Yeah, so for example, FMT have the result and IO have the result, then you probably want to keep the parents. Distinguish the two. Yep. Yeah, I guess like function have this more in common, so people just like, oh, for all the function we just want to see who they are associated with. Other solution, the problem, or you can use as something. Yeah, or you can change the name. Problem solved. Yep. It's up to you. You can do that as well. Spotting names with pub use. When we bring a name into scope, the name is available in the new scope is private. So yeah, you have to export it. If you want to export it, you have to use pub. Okay, quite straightforward. And an internal structure of your code is different from how programmers calling your code would think about the domain. The restaurant, people running a restaurant think about front of house and back of house, but customer visiting a restaurant probably don't think about a part of the restaurant in those terms. Pub use, we can write our code with one structure, but expose a different structure. Yeah. You can just export hosting, so people don't need to know it's the front of house. Using external packages. So we're using ran like this. So we have a dependency, write it in a cargo.toml file. So you can call in anything from the craze.io. Yep, brought the rain tray into the scope. And then we have to do this. So step 1, put your package in the cargo.toml and then use to bring the items into your scope. Standard library is also a crane that is external to our package. Because standard library is shipped with the Rust language, we don't need to put it in a cargo.toml because it's already downloaded. But we need to refer them using use because they are different crane. It's just that it's there all the time. So it's like this. std. Using nested path to clean up a large use list. So if we're using multiple items defined in the same crate or the same module, listing each item on its own line can take up a lot of vertical space. So for example, we have if we have a lot of things that we need to use, then there will be a lot of use. So how do we put them into one thing? So std is the one, and then within you can have this one and this one. Okay, let's make it more compact. So you can self and then write. Okay, like that. The globe operator, so it's like, yeah, stars, we love stars, like in Python. Oh my god, import star, oh my god. So everything, all public items, then we would use the star operator. Be careful, yeah. Make it harder to tell what name are in scope. Yeah, so that's why import star is not a good practice in Python as well. Be careful when you use it with care. Okay, last chapter, last page in chapter 7, I guess. Separating modules into different files. So yeah, we have the restaurant thing, but now it's super complicated. We got many things inside. So if we want to separate them, yeah. multiple restaurant modules. We extract modules into files instead of having all of the modules defined. So front of house would be its own file. So how do we do that? So remove the code inside the curly brackets of the front of house module, leaving only them so that it contains. So we need the front of house rs. So new file. So here we put everything here inside here, and in here we only have this. So it won't compile until we have that file, but we will have a lot of problem, isn't it? Because hosting is still here, but this one, let's see if we have any compilation problem. Yep, no hosting in front of house. So in the name code, oops, I know, because now I'm front of house inside front of house. This is wrong, so I would do this. Oh, then I would have hosting there. Yep, now it's correct. Now the path is correct, because before I made a mistake that I have a front of house inside front of house, so this will be front of house hosting, which is wrong. So yeah, you need to load the files and model decoration once you're in the module tree. It's a child module, front of house, not the root module. We can move hosting as well. So, but I'm not going to do that because it's similar. It's just that you place it in the folder called front of house. Yeah. Alternate file paths. Yeah, you can also put the front of house in the folder and call it mod. It's an old style though, so yeah, probably you don't want to do it like that anymore. Right. Okay. This hasn't changed because the path, like the structure of the module path are the same, so we don't have to change it. Yeah. So I guess that's it. It's a very useful chapter to cover how packages work, how the path work. It's so good that it got documented. Like when I started with Python, it's a nightmare. I don't know what's going on. Like a lot of things can go wrong. Like the structure was the best practice and stuff. It's a guessing game in Python. But here we have, like in Rust, we have the book. I guess this is a common practice that I should also maybe start using more kind of similar structure in Python as well, so that things are not crazily messy. So there you go. We have chapter 7. So I guess, how long have I been streaming? Almost an hour. Oh dear. Yeah, I'm, like I said, I'm quite tired. It's not that I'm not a morning person, it's because I still have jet lag. I'm in the UK, but my body think I'm in Colombia, so it's super early for me right now, for my body at least. Not for my actual life, but for my body. Now it feels like it's super early, but yeah. So I would need more coffee, and I would see if I have time to come back to do more chapters in the afternoon when I'm more awake. But yeah, that's it for me. Um, just a reminder, because like if you see like when I click on the I don't know what's that called, like the video of like the coffee thing with the music. There's a QR code there. There's actually a link to my GitHub sponsor page. So if you want to buy me a coffee, really appreciate that. Um, and also, I am currently looking for a new job. So I am still doing some community work, and I'll be traveling to do some community work. So if you can support my travel, that would also be highly appreciated. So yeah, thank you so much for watching. I will come back to do more, and yeah, there's a lot of chapter here. I hope we would kind of. So the plan is that I would maybe go to chapter 10, and I will do some wrestling exercise here. Oh, it's so bright. Okay, so we'll do some wrestling exercise here up until the thing that we have learned till chapter 10. So we kind of alternate. I won't get like too bored just reading the book, so we can do some exercise and then come back to do the rest of it, which is good. And yeah, so that's it from me for now, and hopefully see you in a few hours. So bye.